So let's give you another example. So we've seen this before. Let's try and determine if this thing here will converge or if it will diverge. So in the past, we would compare this with the integral, and then we would evaluate this integral. But then a more efficient way of doing it would be to realize that this series will always be equal to or bigger than this series. If you look at this, if you compare this with this, natural log of n looks like this. Natural log of n looks like this. So when n is 1, it will be natural log would be 0. When n equals e, then this here will be 1. But then anything beyond e, this thing here will be bigger than the number 1, So anything beyond e, you can see that this will be bigger. This will be bigger than this thing here. So rather, well, but then the thing is, we have to start at e here, but then n can't be a decimal. So e is 2.7 ish. So let's start at 3. So now you can immediately tell. Well, by now you should be able to tell that this thing here this series here will diverge. It's a harmonic series. It will diverge. So therefore, this thing, being always bigger or equal to this thing here, must also diverge. So you could use the integral test, but if you realize that this thing will always be bigger or equal to this thing for n being for n starting at 3, then this thing here will diverge. Therefore, this thing here will also diverge. It's much quicker than the integral test. Okay.